claiming that a 6-mile-wide asteroid crashed into the planet, unleashing the power of 1 billion nuclear weapons is an extraordinary claim. So where is the evidence? Where is the smoking gun?
We've all heard the story. A massive space rock slammed into Earth millions of years ago and wiped out the dinosaurs. But now, thanks to cutting-edge technology, scientists have uncovered a new timeline, and it's revealing far more than we ever imagined. Not only do we have a clearer picture of what happened on that apocalyptic day, but researchers may have finally traced where that killer asteroid actually came from. And here's where it gets even more intense. Could it happen again? Is Earth still in the cosmic crosshairs? And if so, would we stand a chance? What NASA scientists recently discovered might surprise you, and honestly, it's a little terrifying. Let's rewind the clock. It's 65 million years ago, somewhere in what's now North America. Dinosaurs ruled a land, and the Earth is alive with thunderous footsteps and towering lizards. But high above in the night sky, something strange appears. At first, it looks like just another star, twinkling faintly in the darkness. But this star is getting brighter and bigger, slowly, steadily. What you're seeing isn't a star at all. It's a monster, an asteroid the size of a city, hurtling toward Earth at over 45,000 miles per hour. Somewhere between 7 and 50 miles wide, this thing is locked onto a collision course, and there's nothing anyone or anything can do to stop it. Then, impact. The asteroid slams into what's now the Gulf of Mexico, right off the Yucatan Peninsula. The force of the collision is beyond comprehension. Millions of nuclear bombs detonating at once. The water explodes skyward. Firestorms ignite across continents. Debris rains down from the heavens like molten rock. A global tsunami races outward, swallowing coastlines whole. And that's just the beginning. According to a new study published in the Proceedings of the National Academy of Sciences, researchers reconstructed what happened on that very first day of the Cenozoic era, the dawn of a new chapter in Earth's history. Using incredibly detailed imaging, magnetic analysis, and microscopic studies of rock cores taken from the Chicxulub crater, one of the biggest impact scars on Earth, scientists pieced together a chilling, hour-by-hour record of that fateful day. The result? A story of destruction so massive it nearly erased life as we know it. Rocks rained from the sky, global wildfires tore across entire forests. The sky darkened. The oceans surged. Earth wasn't just hit, it was devastated. And here's the haunting part. Scientists now believe they know where the asteroid came from, which means they might also be able to track others just like it. So, what if another one is already on its way? We've survived the last one barely. The real question now is, will we survive the next?
Now picture this.
A space rock the size of a mountain comes screaming toward Earth. This wasn't just a meteor, it was the Chicxulub asteroid, and when it hit our atmosphere, it didn't slow down like most space rocks. It punched through all 60 miles of air in just 3 seconds. Imagine tossing a boulder into a kiddie pool. That's how it crashed through the sky, violent, fast, and unstoppable. As it roared over Central America, the asteroid unleashed the loudest sonic boom in Earth's history, a shockwave so powerful it could have shattered eardrums on every continent. Down below, dinosaurs likely panicked, running in all directions, confused and terrified. But they didn't know what was coming. No one could have imagined what happened next. Any creature close enough to see the asteroid instantly vaporized, gone in a flash. In fact, except for some lucky sea turtles and resilient crocodiles, no 4-legged animal over 55 pounds made it through that day. The asteroid was moving so fast, the air in front of it didn't even have time to move out of the way. Instead, it got trapped, compressed, heated to thousands of degrees in an instant. That superheated air alone was enough to boil away the shallow sea sitting over the Yucatan Peninsula before the asteroid even made contact. And then impact. In a fraction of a second, the asteroid slammed into Earth's crust, hitting with such violent force that rock and soil didn't just break, they flowed. Solid ground rippled like water. It was as if the planet itself was made of liquid. Think of a giant cannonball dive into a pool. First comes the outward splash, then a delayed upward burst. That's exactly what Earth did. The initial explosion blasted rock over 20 miles into the sky, higher than Everest by far. The force was so deep, It nearly cracked through Earth's mantle, and then the ground rebounded upward, soaring at over 1,000 miles per hour. A towering mountain of molten Earth rose from the crater, only to collapse in minutes, triggering a chain of explosive aftershocks and leaving behind a strange ringed peak in the center of the crater. But here's the real jaw-dropper. All of this happened in seconds. The kinetic energy released by the asteroid, a 7.5 billion-ton bullet traveling at 10 miles per second, was mind-blowing. It released more heat and energy than a billion Hiroshima bombs. We're talking about one of the most violent days in Earth's entire history. The energy didn't just crush rocks and boil oceans. It turned molecules to plasma. Temperatures soared beyond the surface of the sun, and in that one moment, Earth changed forever. The moment the Chicxulub asteroid slammed into Earth, it didn't just make a crater, it turned the sky into fire. The heat was so intense, it ripped electrons straight off atoms. In a flash, the air around the impact zone was transformed into a roaring fireball of plasma hotter than 18,000 degrees Fahrenheit, fused with vaporized rock moving at hypersonic speeds. And then came the pressure wave. That mix of superheated air, pulverized Earth turned to gas, and the brutal impact itself triggered an expanding shockwave like a nuclear blast, only far bigger. It ripped outward at over 1,000 miles per hour. To put it in today's terms, if this asteroid hit the same spot now, you'd be vaporized in Texas, deafened in New York, and your windows would shatter in Buenos Aires. This wasn't just a local disaster. The whole planet felt it. The Earth itself rang like a bell. Seismic waves spread out from the impact site at over 8,000 miles per hour, fast enough to shake the far side of the world within 30 minutes. Faults slipped, continents trembled, massive earthquakes rippled across the globe. Then came the water. Within an hour, skyscraper-sized tsunamis, some up to 1,000 feet tall, crashed into the Gulf Coast. The force of the waves was so strong, they reversed the flow of rivers, sending torrents of water upstream. Entire regions were drowned beneath walls of water, but it didn't stop there. The eastern US coast got slammed. 6 hours later, 600-foot-high waves were pounding Europe, Africa, and the Mediterranean like sledgehammers. Within 15 hours of the asteroid's arrival, every coastline on the planet had been hit. Whole cities, if they had existed, would have been swept away, torn from the land, and dragged back to sea by the retreating waves. And just when you think it can't get any worse, it does. The impact was so powerful, it launched 25 trillion tons of Earth into the air. Some of it shot into space. Chunks of molten rock were thrown with such speed they escaped Earth's gravity entirely. Some likely ended up orbiting the sun. A few may have even reached the moon. But most of it came back. Within the hour, that debris rained back down across the planet like a fiery meteor storm. Red-hot rock, ash, and glass fell from the sky, lighting wildfires, heating the atmosphere, and darkening the skies. And all of this happened in less than a day. What started as a single flash in the night sky became a global chain reaction of devastation that changed life on Earth forever. And yet, the worst was still to come. Just when things couldn't get worse after the asteroid impact, they did. As the Earth tried to recover from the blast, the sky opened up again. This time, chunks of molten glass called tektites began falling from the sky like bullets. Most were the size of marbles, but some were as big as buses. And they came down fast, slamming into the ground at 100 to 200 miles per hour. No matter where the last dinosaurs were hiding, whether they were near the crater or halfway around the world, they were caught in this deadly storm. But here's the terrifying part. These glass missiles didn't even have to hit anything to be lethal. As they tore through the atmosphere, the friction they created unleashed a massive wave of heat. Imagine the whole sky turning into an oven set to broil. That radiant heat was enough to ignite forests across the globe. By some estimates, the air got so hot it scorched the Earth in minutes. The result? Most of the world's trees were turned to ash. Only birds that nested on the ground seemed to make it through, likely because tree dwellers were simply cooked alive. For any land animal to have survived, they needed a way to hide. The few that did, like early mammals, snakes, lizards, turtles, and crocodiles either dug into the ground or escaped into water. If the dinosaurs had a chance, they would have needed to do the same. But their luck was about to get even worse. The asteroid didn't just hit any patch of land, it slammed into an area rich in oil and sulfur. That was a catastrophic twist of fate. The impact vaporized 100 billion tons of sulfur and blasted it into the sky, along with an ocean's worth of water. That mix turned into giant storm clouds and came back down as acid rain, poisoning the oceans and turning the skies toxic. In colder regions, it snowed with terrifying intensity, tens of feet per day. But even that wasn't the final blow. The explosion also ejected a mind-blowing amount of oil, enough to fill 150 football stadiums, which condensed high above the Earth into a black, sooty layer. This wasn't just smoke from wildfires, it was pure carbon, floating high in the stratosphere, too high to be washed away by rain. That layer blanketed the planet like black paint, sealing in darkness. And then came the cold. With 90% of sunlight blocked, photosynthesis collapsed, plants died, food chains broke down, and global temperatures didn't just dip, they plummeted, dropping by nearly 50 degrees Fahrenheit on average. After the fiery storm, Earth entered a deep freeze that lasted for years. What began as a blinding flash in the sky ended in near-total silence, a frozen world, a dying planet. And that was the final chapter in the age of the dinosaurs. After the giant impact that wiped out the dinosaurs, Earth was plunged into a global deep freeze. But not everywhere froze. A few lucky places, what we now call...
But here's the burning question.
Where did that monster asteroid come from? And more importantly, could it happen again? Scientists have been digging into that mystery. Using supercomputers and asteroid tracking data, two researchers, Avi Loeb and Amir Siraj, think they've found the answer. Their theory? The Chicxulub asteroid came from the Oort cloud, a distant sphere of icy debris way out at the edge of our solar system. They believe a much larger comet was knocked off course by Jupiter's gravitational pull, slung toward the Sun, broke apart, and sent one of its deadly pieces straight to Earth. And here's the unsettling part. These cosmic fragments can cross Earth's path every 250 to 730 million years. So, it's not a matter of if another asteroid could strike, it's a matter of when. In fact, we recently had a close call. On Saturday, December 11th, 2021, a giant asteroid named 4660 Nereus, over 1,000 feet long, flew past Earth at 6.5 kilometers per second. That's 14,500 miles per hour. It came within 3.8 million kilometers of Earth. Sounds like a lot, right? Not in space terms. A small nudge in its orbit and boom, it's on a crash course with us. And get this, Nereus is scheduled to come even closer on Valentine's Day 2060, within just 1.1 million kilometers of Earth. So maybe go ahead and buy those roses early, just in case. To give you some perspective, the asteroid that exploded over Chelyabinsk, Russia in 2013, it was only 66 feet across. Still injured over 1,500 people. Now imagine one 330 meters long heading straight for us. The truth, right now, we don't really have a guaranteed way to stop a planet-killing space rock, but NASA's working on it. Enter DART, the Double Asteroid Redirection Test. It's a bold mission to see if we can knock an asteroid off course by literally crashing a spacecraft into it. The idea is simple. Give the asteroid a hard enough push called a kinetic impact and hopefully steer it away from Earth. DART is targeting a small moonlet called Dimorphos, which orbits a larger asteroid named Didymos. The plan? Slam into Dimorphos in late September 2022, when the system is about 11 million kilometers from Earth. The expected change in speed? A tiny fraction of 1%. But when we're dealing with cosmic billiards, that could be enough. Still, if we're ever faced with a 10-kilometer wide asteroid barreling toward us at 45,000 miles per hour, it'll take a lot more than a single spacecraft. Maybe we'd have to go full Armageddon nukes and all.